Okay, so welcome to Mathstoria, and we're going to solve this problem. So it has been found that 85.6% of all enrolled college and university students in the United States are undergraduates. So a random sample of 500 enrolled college students in a particular state revealed that 420 of them were undergraduates. So is there a sufficient evidence to conclude that the proportion differs from the national percentage? So use alpha that's equal to 0.05. So we're going to solve this problem using the steps in hypothesis testing. So for step 1, we need to state the null and the alternative hypothesis. So for the null hypothesis, since we have this 85.6%, then to convert this one to decimal, that's 0.856, and this one is the population proportion. So we need to assume that the population proportion is equal to 0.856. Then for the alternative hypothesis, since we need to test if the proportion differs from the national percentage, so therefore the population proportion is not equal to 0.856. So this is the null hypothesis, and this one is the alternative hypothesis. Then for step 2, we need to specify the level of significance. So alpha is equal to 0.05. Since in the alternative hypothesis, this one is not equal, so therefore this one is two-tailed. Then for step 3, so we need to identify the critical value. So from the given level of significance, so alpha is 0.05 and two-tailed. So in the table, since two-tailed and alpha is 0.05, so the critical value is 1.96. Since two-tailed, so we have positive 1.96 and the negative 1.96. This is now the rejection region, and this area is the non-rejection region. Then for the computation, so using this formula, so the sample proportion minus the population proportion over the square root of the population proportion times 1 minus the population proportion over the sample size. So we need to compute first the sample proportion. So from the given sample size, that's 500, then we have this 420, so we need to compute what is 420 in 500. So that's 420 divided by 500. So 420 divided by 500, that's 0.84. Then to solve now for z, so we have sample proportion, that's 0.84. Then minus the population proportion, so this one in decimal, that's 0.856. Then over the square root of the population proportion, that's 0.856 times 1 minus 0.856 over the sample size. This one is n, that's 500. Then to solve for z, so we have 0.84 minus 0.856, that's negative 0.016. Then over, so this 0.856, then open parenthesis, 1 minus 0.856, close parenthesis, that's 0.123264. Then divide by the sample size, so divide by 500. So we have 0.0002465. Then simplify, so this square root of 0.0002465. So the square root of 0.0002465, that's 0.157. So 0.0157. So to solve now for z, So negative 0.016 divided by 0.0157. So z is negative 1.02. So this is now the value of z, that's negative 1.02. Then for the implication, since z is equal to negative 1.02, since z is negative, so we're going to use the negative critical value, that's negative 1.96. And this negative 1.02 is greater than negative 1.96. Then from the rejection region, so from this area we reject the null hypothesis, and also from this area we reject the null hypothesis, and on this area we accept the null hypothesis. Now since our computed z value is equal to negative 1.02, and this negative 1.02 belongs to this area, so therefore we accept the null hypothesis. So accept the null hypothesis. Since we accept the null hypothesis, so accept the null hypothesis and we reject this alternative hypothesis. So therefore the population proportion is equal to 0.856. So therefore there is a sufficient evidence to conclude that the population proportion does not differ from the national percentage.